Hi, everyone. So my name is Sarah. I work for a company called Casne Engineering, as Mike just said. We are a systems integrator. I'll talk a little bit about what we do, but I really want to focus this next 10 minutes on a couple of really cool use cases that boil down to, an issue we're seeing a lot, which is like, okay, we got all this data, our plants run pretty good. What's next? What can we now do given that we have this data and some situational awareness? Perfect. Okay, so just a little bit about us. Casne is headquartered up in Bellevue, Washington, although we have a presence all across the United States and a little bit of Canada. We are full service, so we do all sorts of different type of engineering things, from power and controls to all of the cool data stuff we're mostly here to talk about today. Also have a few products which will feature in the discussion we're about to have. So just a little bit about us. The first use case I want to talk about is the City of Salem. I just moved to Massachusetts, and now Salem is a little witchier, but this is Oregon Salem, so our neighbors to the north. And the goal here was, okay, we've got a bunch of data. We want to share it. We want to be able to use it and pull it out of this silo, because right now, all of Salem's data was in industrial control systems, right? So what do we do with this? Well, a couple things. We've been working with Salem for about the last 10 years, and the very first thing we did to help them break that silo was to build them a PI system, take all of that Foxborough data from various other utilities, bring it all into one centralized location so we can use it, build a nice AF structure on top of it. Okay, so far so good. But now that's still data that's sitting in Salem's systems. So how do we disseminate this to other people who need it? A couple things we did. We used Connect to take data from PI and bring it into a processing platform that allowed a University of Oregon team to analyze water quality and help ensure that the water they were working with was up to code. We also used a Casne utility called CloudStream to bring the data into Esri and Power BI. So let me advance here a little bit. This is said utility. Effectively, we can take all that PI data and then fan it out to wherever we want to go through various different connectors. The Esri one is one of our favorites. It has really helped, especially a lot of our water and wastewater customers, get data from PI into Esri. This allowed Salem to basically create this map where they're showing where water is flowing throughout their system at any time, help them anticipate storm incidents. But even more importantly, anyone in Salem can go, or not even Salem, right, can go to this website and see what's going on, right? It allowed them to be more transparent about how they're using their data, which was one of their big goals. We also were able to use that CloudStream application to bring data into Power BI. So this is the web application version of Power BI, mobile application. And what this allowed us to do was enable field engineers to go out to different sites and have that data on hand ready to use, right? So making more informed decisions about their assets and how to do certain maintenance tasks based on real-time data. So Salem has a lot of disparate systems, right? They've been an AVEVA customer for a while. They use Power BI. They use Esri, all sorts of different systems. The PI system and the analytics and integrations we were able to do around it are really what enabled all of this to kind of come together and be more effective for them. So that's the first thing I want to talk about. Second example is our friends San Jose Water, so a little closer to home. Similar situation. They have all this data, tons and tons of pumps scattered across the city. What do we want to do with it? Well, what San Jose Water really wanted to do was to run their system more efficiently and look for options for proactive maintenance. Now, this is obviously challenging for many reasons, right? Once you have your even once you have your data visible and in a historian you can work with it, they got many, 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 many assets, right? How are you going to monitor these at scale? So in order to make this work, several different things had to come together. They were a system platform user back when system platform was Wonderware. So the first thing we did for them was, once again, brought all that data into Pi, built them a nice AF structure so they could keep track of all of their pumps. Pretty extensive one, but at least everything was now cataloged and workable. And then we were able to do some really cool analytics on top of it. One of the earliest things we did, I'll jump here to the next slide, was build these are both vision dashboards that brought in things like time of use data and pump curves. So we could build, let me go back and see if I got a pump curve. Oh, no. So we could build analytics that could not only say, okay, this is where we expect these pumps to be running. Are they actually running there? If not, let's do something about it. But also, bringing in some utility data, we could look at when they were running their pumps and say, okay, well, if we run pumps in the morning, it's substantially cheaper than if we run them in the afternoon during peak. They could make some calculations to optimize the best time to run their assets. This one was also pretty nice because not only were we able to find some efficiencies in terms of when to run, but we were also able to catch some pretty significant billing issues that have now saved them upwards of $500,000 a year in recovered billing costs for electricity. So they were pretty pleased about that. Recently, we said, okay, so we can now determine, are the pumps on or off spec? But over time, things move. You've got 500, 600 assets. How do we know which ones to target at any point? So we implemented another Casne tool called Casne Limit Learner. Super basic ML, not anything too fancy. But what it did was it baselined all of their vibration data, power data, etc. And so we could see, okay, well, over time, this is an example of a vibration trace, right? Over time, it looks pretty normal, and then suddenly they have an issue. We have associated alarming in Pi that started kicking in right about here, and we could say, ooh, vibration not looking so good on this particular pump. They sent a maintenance crew out, found an oil leak, saved the pump. So now we've pushed one step further into, okay, what can we do with all this data? Well, now we can do proactive maintenance and do it at scale, right, over many, many, many assets. So we aren't having to track things down individually. We can have a way more efficient way to bring it all together. That's all I got for y'all today. Any questions?
Any questions for Sarah? All right, thanks, Sarah.
Cool, thanks so much.
Good job, thank you, Sarah.
Thanks.